basics in organic chemistry, we must know what is organic compounds. So any organic compounds are chemical compounds contain carbon-hydrogen bond. Okay. Now in methane, it is an organic compound because it possesses carbon-hydrogen bond, but carbon dioxide is not an organic compound. Okay. So that's the thing. So after knowing this organic compound, the first thing is you must understand what are electrophiles, okay, and what are nucleophiles. This is very important basics in organic chemistry. Now the electrophiles, of course, they are electron deficient species, and they can donate the electron, they can accept the electron pair. Why? Because deficiency, they are deficient, they cannot donate the electron pair. So they are the one which accepts electron pair, okay, and when it is accept, so they must be deficient. But in nucleophile, they donate the electron pair. So when they donate the electron pair, so what happened? It is electron rich. So that's why we must understand the first basic definition of electrophile and a nucleophile. So electrophile, electron loving. Why electron loving? Because they are having deficiency of electron. Okay. Nucleophile, the nucleus loving. Nucleus do not contain electron, so that's why they can donate the electron pair to any functional group or any molecule which is having deficiency of electron. So ideally nucleophile donate the electron to the electrophile in organic chemistry reaction. Now, so how to start with the things? Now apart from that, you must know any cation can behave like electrophile because cation means deficiency, and any anions can behave like nucleophile. Right? For example, if you have CH3 plus, okay, it is electrophile, but the CH3 minus, it is known as nucleophile. Normally, if you use the reagent CH3Cl, okay, methyl chloride, it generates an electrophile. But if you use Grignard reagent, okay, Grignard, so that generates CH3 minus. Similarly, you have example Cl plus, Cl minus. Now your OH minus and Cn minus, it's only minus, they do not have a plus things. Okay, we cannot write OH plus and Cn plus, no. And then you have NO2 plus, which is an electrophile. Okay, of course you have an H plus, an electrophile, but you have also H minus, which is nucleophile. Okay, then after this we go ahead with understanding of electrophile and nucleophile with the help of carbon, because organic compounds, nothing but it's a, any chemical compound contain carbon and hydrogen. So first we will discuss about the carbon compounds. So now when we are talking about carbon, you remember the first thing is that is carbon's hybridization. Okay, if you talk about CH3, in this format carbon hybridization is sp3. So remember, whenever a functional group or a molecule or a part of the molecule, okay, hybridized in sp3 manner, okay, so they automatically act as nucleophile. And why it is? Because the pi electrons, the p character, if the p character is more, then the loosely bound electrons also more. Okay, when the electrons are loosely bound, it can be easily donated. But if it is sp, then it is s character is more. So in that case, it is strongly bound. So I'll come to that. So after that, the nucleophile. These are the nucleophile. But now, if you're talking about C double bond C, okay, or C triple bond C, both the cases, even though it is an sp2 hybridized form of carbon, and this is an sp, in both the cases, it is nucleophile. Why so? because the electronegativity, there is no difference in the electronegativity. Whenever a functional group or carbon attached to another carbon, there is no electronegativity difference, and that's why their P character is not affected. Okay, of course you can say that when there is no electronegativity difference, the double bond can be available for donation. So whenever any molecule donate electron, they known as nucleophile. Of course these are the two exceptional, but when you are talking about carbonyl compound, C double bond OR, okay, this carbonyl compound, if you see oxygen and carbon, they have different electronegativity. I'll come to that point, what is electronegativity. So in that case, these compounds are electrophiles. So I'll just dictate what are the carbonyl compound. Like for example, you have aldehyde, okay, CHO you can write in this fashion for aldehyde. Then you have ester, then you have amide, then acid chloride, then you have carboxylic acid, then you have also anhydride, okay, and peracid, COOH. So if you see, this is peracid because it contains peroxy bridge. Okay, so these are the important. So this is ketone, this is aldehyde, and entire these examples are belong to electrophile. Okay, and why the electrophile? Because there is a difference in electronegativity. Whenever this is formed between the two different electronegative atoms, the higher electronegative contain delta minus and the lower electronegative contain delta plus. Okay, this delta notation is given by a very famous scientist that I will discuss in, of course, my electronegativity session. Okay, so that can be a good question for NIPER or GPAT. So now after this, so let us move on to the sp hybridization. So these are the sp2 hybridization of carbon, where these are known as electrophile. You have sp hybridization of carbon, that is CN, which is known as nitrile group or cyano group. Okay, this is electrophile, but you should not be confused with Cn minus. Okay, this is cyanide, which is nucleophile.